valve operating mechanism and valve timing diagram for 4-stroke IC engine. Valve operating mechanism consists of several components such as crankshaft gear, cam gear, crankshaft, push rod, tappet and rocker arm. There may be another small parts which are very much important for the operating mechanism of the valve. The crankshaft gear operates the cam gear which is fixed at one end of the camshaft. See in the figure, this is the crankshaft and this is the camshaft. So one gear is mounted on the crankshaft which is of small size and another gear which is big size is mounted on the camshaft. So through this either gear mechanism or sprocket and chain mechanism, this power from the crankshaft is available to the camshaft for rotating on its own axis, and this camshaft lift the valve with this valve mechanism. So it is important to note that the camshaft has not having its own power, but it is receiving the power from the crankshaft, and size of the either gear or sprocket of camshaft is double that of the crankshaft. So see, just we will study different parts and before that we will see all these parts that are included in the valve mechanism. See, this is the camshaft and this is the cam gear. This is the crankshaft and a small gear is fitted over the crankshaft. This is the tappet. This is the push rod. This is the cam. The portion which is oval in shape and which lift the tappet as and when the cam rotate, this lobe or cam push the tappet upside, and through this upward movement the push rod goes up and it pushes the rocker arms or rocker arm shaft upward, and due of the linkage the other end of the rocker arm pushes the valve on the downside, and due of which the valve goes inside the clearance volume and this valve opening becomes open, and either if it is a inlet valve then fresh air or air fuel mixture comes in the cylinder, or if it is exhaust valve then whatever exhaust gases that has been produced after the burning of the fuel goes out through this opening. So this is the, we can say, valve operating mechanism. Consequently, camshaft rotates and moves the tappet which pushes the push rod in proper time, as I have explained in the figure. Thus, push rod opens or closes the valves at predetermined interval. Means push rod goes upside and that operates the rocker arm, and due to the down movement of other side of the rocker arm, the valve is pushed inside the cylinder, and that's why valve head goes inside and the space of the admitting fresh air into the cylinder clears. So fresh air enters in the inside the cylinder in the inlet valve, and if it is exhaust valve then whatever burnt gases that has been produced during the power stroke goes out as and when this exhaust valve open. So thus push rod opens or closes the valves at predetermined intervals. The camshaft gear is double the size of the crankshaft gear, so that there is one revolution of camshaft for every 2 revolution of the crankshaft in case of the 4-stroke engine. Now we will see all these parts individually. First we will see the valve. See, there are 2 valves in the 4-stroke engine for each and every cylinder piston assembly. If it is 4-cylinder 4-stroke engine, then there will be individual pair of 4 intake and exhaust valve. Suppose for this one cylinder there is a one intake valve and one exhaust valve. So there is a pair of inlet as well as exhaust valve for each and every cylinder. First we will see valve. A valve is a small mechanical device used for opening or closing the passage leading to the engine cylinder. Means whatever the opening leading to the engine cylinder is either opened or closed through this valve. So this is the valve. If it is inlet valve then it opens and the fresh air enter in the cylinder. If it is exhaust valve then whatever burnt gases that has been produced during the power stroke is expelled out during the exhaust stroke. So there are 2 types of valve, inlet valve and exhaust valve. Now we will see inlet valve. A small mechanical device used for opening the passage leading to the engine cylinder for the entry of air or for air fuel mixture in the engine cylinder is called the inlet valve of an internal combustion engine. We know that in the 4-stroke diesel engine only air is introduced during the suction stroke or intake stroke. So this inlet valve opens during the suction stroke. See, this is the inlet valve. As and when the cam gives upward movement to the tappet, and through this upward movement, push rod pushes the rocker arm on the upside, and due of which the other end of the rocker arm press the valve inside. So this valve goes inside through this inlet valve. In the 4-stroke engine, fresh air comes in the clearance volume, or we can say inside the cylinder. So, but our engine is of 2-stroke, then in that case, air fuel mixture enters in the cylinder at the time of intake stroke. Now, second is exhaust valve. See, this is the exhaust valve. A small mechanical device used for closing the passage leading to the engine cylinder for the exit of burnt gases from the engine cylinder is called the exhaust valve of an internal combustion engine. So, during the power stroke, due to the production of the burnt gases, there will be the exhaust gases, and that exhaust gases is expelled out through this exhaust valve during the exhaust stroke. Now, inlet valve of an internal combustion engine allow air or air fuel mixture to go into the combustion chamber. The exhaust valve allows burnt gases to go out of the engine cylinder. So, function of both the valves are different. Inlet valve allows the fresh air to enter in the engine cylinder, while exhaust valve allow the burnt gases to expel out during the exhaust stroke. Now, valve head. See, this is the valve head. It is made of special alloy which can withstand high temperature and hammering action due to the expanding gases. As this valve open in the clearance volume of the cylinder, so this portion, the valve head, is always in touch with the clearance volume, and during the power stroke, due to burning of gas, there is a high temperature, as well as due to the expanding of gas, there is a hammering action inside the cylinder. So this hammering action as well as high temperature must be withstood by this valve head. So it is made of special alloy which can withstand high temperature as well as hammering action of the expanding gases. Then valve stem. See, this is the valve stem. It is a round steel rod attached with the valve head. See, the extended rod through the valve head is called the valve stem. Valve stem guide. See, this is the valve stem guide, in which valve is perfectly going up or down. Clear movement of the valve during its opening and closing. This valve stem guide helps to have close fitting with it. It is the small guide which fits into the cylinder block. See, this is the cylinder block, or we can say cylinder head, in which this valve stem guide is fitted. It is usually made of cast iron. In some cases, a rimmed hole in the block also serves as valve guide. Means mostly it is made of cast iron, but in some cases a hole that is rammed in the cylinder block serves as a valve guide. So in that case there may not be special arrangement of valve guide, but a hole is rammed inside the cylinder block, and this hole serves as a valve stem guide. See here, the valve seat as well as valve seat insert is given. So by this arrangement of valve seat and valve insert, the valve can easily fit into the gap, and it either block or as and when it is go down, then it clear the space, and through which either if it is inlet valve, then fresh air comes inside the cylinder, and if it is exhaust valve, then whatever burnt gas is that goes out from the cylinder. So some clearance is given, and this valve head is fit with valve seat for opening and closing of the valve. See, this is the camshaft, and this is the lobe or cam on the camshaft. This is the tappet which is in close touch with the camshaft, and as and when this extended portion touches the tappet, then tappet lift the push rod, and through the upper action of the push rod, the motion is transmitted to the rocker arm, and the other end of the rocker arm pushes the valve the downward side in the clearance volume, or we can say on the head of the cylinder, and that's why it open in the cylinder. Now cam gear. A gear fixed at the end of the camshaft to match the crankshaft gear is called the cam gear. See, this is the cam gear, which is mostly double the size of the crank gear, because for 2 revolution of the crankshaft, there is a 1 revolution of camshaft, because in the 2 revolution we have 1 power stroke, and during this 2 revolution we have to either open or close the inlet or exhaust valve 1 times. So the speed, or we can say the rotation of the camshaft gear, is slower by putting this gear bigger than that of the crankshaft gear. Tappet. Tappet is also called valve lifter. Tappet rises or lower the valves, as we have seen in the figure. See, this is the tappet, and as and when it comes contact with the extended portion, or we can say cam of the camshaft, then it lift up and gives the motion to the push rod. It receives motion from the cams mounted on the camshaft. It opens or closes the valve at proper time. It is usually made of hardened steel, as it is always comes in contact with the cam or cam lobe. That's why it is made of hardened steel. Valve lift rides the cam lobe and helps in opening the valves. Means it rides the cam lobe, means in touch with the cam lobe and helps in opening the valve. Rocker arm. See, this is the rocker arm. It is an arm used to change upward motion of the push rod to the downward motion for opening an engine valve. See, here in the figure we will see this is the rocker arm. The upward motion of push rod lift this end of the rocker arm, and due to upward movement of this arm, the another end of the rocker arm will push downward, and that downward motion is transferred to the valve. So due to the arrangement of spring, the valve goes in the downside and open the space of the either it is inlet or exhaust valve. It is a small rod, one end of which touches the end of the valve stem and another end touches the upper end of the tappet rod, as I have explained the figure. Then tappet clearance. It is the clearance between rocker arm and valve stem to enable the valve to sit properly. As all these parts are given in this figure, so you can easily understand various parts of the valve timing mechanism. See, special spring is given. Generally in steady state condition, it gives the pressure to the valve, and that's why the valve closes the space, either it is inlet space or exhaust space. But as and when the rocker arm pushes the valve stem in the downward side, then at that time, due to the pressure on the spring, this valve also goes downward side and it opens the space. But as and when this force of the rocker arm over, then the valve automatically goes upward due to the action of the spring. So this spring helps valve either to open or remain closed by its elastic motion. See, this is the complete diagram which shows various parts of the valve mechanism. See, in this figure, as and when this cam lobe touches the push rod, then it lifts the rocker arm, and due to the upward movement of this end of the rocker arm, the other end goes down and it pushes the valve in the downside, and that's why the opening will open, and if it is inlet valve, then fresh air enter in the cylinder. But if it is exhaust valve, then the exhaust gases or burnt gases expel out or goes out from the cylinder. So for 4-stroke engine, for each and every cylinder piston assembly, there is a inlet valve as well as exhaust valve. So if our engine is 4-stroke 4-cylinder, then there is a 4 inlet valve and 4 exhaust valve, means a pair of inlet and exhaust valve for each and every cylinder piston assembly. See, in this figure you can easily understand how cam lobe touches the push rod and it either open or close the valve. This is the overhead valve mechanism, and there are 2 cam shafts, one for inlet valve and another for exhaust valve. In some engine there is a 2 cam shaft, one for inlet valve and one for exhaust valve, and there may be arrangement of cam on either on the upper side of the engine head or it may be at the lower portion. So depending upon the types of engine, the number of cam shaft as well as its mounting either on the top or bottom you can see in different types of engine. Now we will see the valve timing diagram. Ideally, we know that during the suction stroke, we will see in the figure, this is the ideal diagram of, or we can say a valve timing diagram showing the ideal position according to the principle. See, as and when piston starts from their movement from the top dead center and it goes to the bottom, then the crankshaft rotation is of 180 degree. So during this stroke, inlet valve opens, and due of which there will be entry of fresh air inside the cylinder. So from piston moves from top dead center to the bottom dead center, there will be entry of fresh air through the opening of the inlet valve. At that time, exhaust valve is closed. After reaching the piston at bottom dead center, then it again travels from bottom dead center to the top dead center. At that time, both the valve, inlet valve as well as exhaust valve, both are closed. So this is the compression stroke, during which inlet valve as well as exhaust valve both are closed, and whatever air that had been introduced during the suction stroke is compressed, and due of which there will be high temperature as well as high pressure, and as and when this piston reaches at the top dead center, the whole air that has been sucked during the suction stroke is compressed in the clearance volume of the cylinder. So at that time, there is a high temperature as well as very high pressure, and at the same time, through the fuel injector, we are generally injecting fuel inside the clearance volume of the cylinder. As the fuel is injected, due to the high pressure and high temperature inside the clearance volume or inside the cylinder, or we can say inside the combustion chamber, the air fuel mixture automatically ignite. There is no need to have spark plug, because the temperature of the compressed air is high enough to ignite the air fuel mixture. So due of which the air fuel mixture ignite, and there is a expansion, expanding gases compress the piston to the downside. So piston moves from the top dead center to the bottom dead center, and this is the power stroke. During this, we can get the power. So it is the real stroke in which we are generally getting the energy or power. So at that time, this inlet valve as well as exhaust valve both are closed. As and when the piston reaches at the bottom dead center, then the exhaust valve open, and at that time, inlet valve remain closed. So as piston moves from the bottom dead center to the top dead center during the exhaust stroke, the exhaust remain open, and the burnt gases that has been generated during the power stroke is expelled out through the exhaust valve. So in the 4-stroke, suction, compression, power and exhaust, power stroke is the only stroke in which we are getting energy or power. Other 3 stroke are ideal stroke, and this is the ideal situation in which we can say during the suction stroke only inlet remain open, and during exhaust stroke only exhaust valve remain open. In other stroke, both the valve remain closed. Either it may be compression stroke or it may be power stroke. During both the stroke, both the valve, either it is inlet valve or exhaust valve, that remain closed. This is the ideal situation which we can say. But in real, the valve opening or closing is a physical phenomena. Means if valve is open, then it requires some time. So it is necessary to have certain time in advance for proper opening of the valve. So in real, the inlet valve opens 25 degree in advance during the earlier exhaust stroke. So if there is a exhaust stroke is running, then at that time, before piston reaches the top dead center, the inlet valve opens at 25 degree in advance. We will see one by one. See, if your engine is continuously going on, then in that case, during the earlier exhaust stroke, the piston is moving from bottom dead center to the top dead center, and at that time, exhaust valve is open to expel out the exhaust gases. But before 20 degree rotation of the crankshaft, or we can say our piston is not traveling up to the top dead center, and there is a 20 degree difference, at that time inlet valve opens before start of the suction stroke. So the inlet valve opens early with respect to the top dead center position of the piston. This compensate for slow opening of the valve, meant for silent operation. Means the opening of valve is a physical phenomena, so it requires certain time. So for full opening of the valve or perfect opening of the valve, the opening of the inlet valve starts in the previous exhaust stroke just before 25 degree of the top dead center. So before 25-degree angle of the crankshaft rotation at piston position of top dead center, the inlet valve opens and our suction stroke starts. See this here, piston is not reached at the top dead center, and this is the exhaust stroke of earlier cycle. So at that time, inlet valve start to open, and it start to open before 25-degree of the movement of the piston with respect to the rotation of the crankshaft in the cylinder. So here in real, inlet valve opens before inlet stroke start. This is the top dead center and this is the bottom dead center. In the previous exhaust stroke is running, then at that time before reaching the piston at top dead center, at early 25-degree angle of the or early 25-degree rotation of the crankshaft, the inlet valve start to open and our intake stroke start. Now during this intake stroke or suction stroke, the inlet valve remains open and piston moves from top dead center to the bottom dead center, and after piston moves from bottom dead center to the top dead center in the compression stroke for the 30-degree rotation of the crankshaft, the inlet valve remain open. So inlet valve remains open for about 180 plus 30-degree plus 25-degree. Similarly, the late closing after the bottom dead center position of the piston is meant to accommodate maximum air molecules inside the cylinder. Means why we are arranging that the inlet valve close after 30-degree rotation of the crankshaft after we can say bottom dead center, because we have to admit maximum air inside the engine cylinder. So as and when the compression stroke start and piston moves from the bottom dead center to the top dead center, at that time inlet valve remains for about 30-degree rotation of the crankshaft, and maximum amount of the air molecules can be entered or can be taken into the cylinder of our engine. So that's why our inlet valve opens 25-degree advance and it closes 30-degree late during the movement of the piston from top dead center to the bottom dead center in the suction stroke. You can say this is the top dead center and this is the bottom dead center. Inlet valve open mostly 10 to 25-degree before TDC and it closes mostly 30-degree to 50-degree after TDC according to the types of engine and system of engine. The opening or closing may be different. So as I have explained, the actual opening or closing of the inlet valve during the suction stroke is maybe inlet valve open 10 to 25-degree before piston reaches at top dead center, and it closes 30 to 50-degree after piston travels from bottom dead center towards the top dead center. So there is a clear, we can say, opening during the opening stage as well as it closes late. So there will be maximum admission of the air molecules in the cylinder. Now inlet valve timing. Due to the effect of inertia and time required to attain the full opening, the inlet valve open somewhat earlier at top dead center, so that by timing the piston reaches top dead center, the inlet valve is fully open. Means opening of the inlet valve is a physical phenomena. So there is a effect of inertia and it requires the time to attain the full opening of the valve. So for full opening of the valve, as and when the piston reaches a top dead center, it is necessary to have action of opening in early. So generally in the previous cycle, the exhaust stroke is running. At that time, inlet valve start to open 25-degree before piston reaches at the top dead center. So this is the cause why valve is opening in advance. If the inlet valve is closed at the BDC, means at the piston reaches at the bottom dead center, the cylinder will receive a charge less than its capacity and pressure inside the cylinder would be somewhat less than the atmospheric pressure. Means why inlet valve closes late after 30-degree when piston is traveled from bottom dead center towards the top dead center at the compression stroke. Due to late closing, there will be maximum amount of charge that can be entered inside the cylinder. So to increase the charge inside the cylinder and to eliminate the, we can say, vacuum pressure inside the cylinder, less pressure than the atmospheric pressure is called the vacuum pressure. So intake valve closes late in the compression stroke. Now after the bottom dead center, the piston goes on the upside towards the top dead center and this compression stroke start, and at that time after 30 degree inlet valve also close and both the valve remain closed. But as and when piston is little far, we can say 5 degree less rotation of the crankshaft, there is a injection of the fuel inside the clearance volume or inside the cylinder. So injection of fuel start just before 5 degree rotation of the crankshaft, means piston is not fully reached at the top dead center and there is a, we can say, lagging of 5 degree. At that time this fuel injection pump start to inject the fuel, and this fuel injection remains up to 25 degree in the power stroke. So this is the position to inject the fuel in the 4-stroke engine during the, we can say, end of the compression stroke and starting of the power stroke. See here, piston is not fully reached at the top dead center during the compression stroke, and at that time this injector inject the fuel just before 5 degree of the crankshaft rotation. So injection of the fuel start before 5 degree when the piston is not reached at the top dead center, and it inject the fuel up to 25 degree when piston is traveling from top dead center to the bottom dead center in the power, or we can say our expansion stroke. See, we will see the fuel injection timing. The opening of the fuel valve, or we can say our fuel injectors before top dead center, is necessary for better evaporation and mixing of the fuel. Means if we are injecting the fuel 5 degree in advance, then there is a better evaporation of the fuel inside the combustion chamber and air fuel mixture will be proper. So for proper mixing as well as proper evaporation, the injection start well in advance. As there is always lag between ignition and supply of the fuel, it is always necessary to supply the fuel little earlier. Means there is a certain lag between ignition and the supply of fuel. So if we supply fuel little advance, then at the proper time we can ignite the air fuel mixture. So this is the cause why we are supplying fuel little in advance. In case of the diesel engine, the overlapping period is sufficient large, that is 45 degree compared with the petrol engine 13 degree. Means in the petrol engine there is a 13 degree overlap time, and in the diesel engine the overlapping period is 45 degree. Overlapping period means the period in which the exhaust valve as well as inlet valve both remain open. Now we can see fuel injection period, that is 5 degree in advance plus 25 degree in the expansion, or we can say our power stroke. So it will be 30 degree, and this 30 degree may be termed as a fuel injection time. More overlapping is not advisable in petrol engine to avoid loss of air fuel mixture with exhaust gases. As we know that in the petrol engine there is a mixed stroke. During the backward stroke, the fuel is also comes in the cylinder as well as exhaust gases goes out from the cylinder. So if there is a more overlapping period, then in that case mixture of burnt gases as well as fresh fuel enter in the cylinder may go out during this overlapping period. So overlapping period in the petrol engine is small as compared to the diesel engine. Thus danger does not arise in case of diesel engine because only air is taken during the suction stroke. So this indicate the overlapping in case of diesel engine as well as in petrol engine. In diesel engine only air is sucked during the suction stroke. So if overlapping period is more, then only air may be expelled out during the exhaust stroke. So there is a no loss of fuel in the diesel engine, or we can say our 4-stroke engine. So overlapping period is more in the diesel engine or 4-stroke engine, but in the petrol engine or our 2-stroke engine, air fuel mixture as well as exhaust gases will be inside the cylinder. So if there is a more overlapping time, then this mixture goes out from the cylinder and we can lose our petrol during this more overlapping time. Now exhaust valve timing. To supply more amount of fresh charge, complete cleaning of exhaust gases from the cylinder is required. Means during the suction stroke, if we want to have sufficient fresh charge inside the cylinder, so for that we have to completely clean the exhaust gases during the exhaust stroke. For that, generally during the exhaust stroke, the exhaust valve remain open in the late. Earlier opening of the exhaust valve before reaching the top dead center facilitate the removal of burnt gases. See here in the power stroke, see this is the power stroke. In the power stroke, or we can say expansion stroke, piston travels from top dead center to the bottom dead center, and at that time before 45 degree of the rotation of crankshaft, or we can say piston is not reached up to the bottom dead center, the exhaust valve start opening. So early opening of the exhaust valve facilitated the full opening of the exhaust valve, and that's why during whole exhaust stroke the burnt gases can be easily expelled out from the cylinder, and that's why more fresh air can be accommodated in the suction stroke. And this exhaust valve remains open after piston reaches at top dead center and travels to the bottom dead center up to, we can say, 15 degree rotation of the crankshaft. So more time to remain open for the exhaust valve facilitate the complete evacuation of the exhaust gas from the engine cylinder, and that's why it facilitates to have more fresh charge during the suction stroke. The kinetic energy of the fresh charge may also assist the removal of the burnt gases. Means, as we know that inlet valve open well advanced 25 degree during the exhaust stroke. So due to the kinetic energy of the fresh charge which are entering during the early 25 degree of the inlet valve, the fresh air enter in the cylinder and it force the exhaust gases to expel out from the cylinder. So this energy of fresh air which is entering in the exhaust stroke inside the cylinder forces the exhaust gases to go out in the cylinder. The closing time of exhaust gas affect the volumetric efficiency. Means due to the entry of the fresh charge more, there will be more volumetric efficiency in the 4-stroke engine. Now valve overlap. It is obvious from the valve timing diagram that the inlet and exhaust valve are open at the same time. See, before 25 degree of the inlet stroke, the inlet valve remains open, and after mostly 15 degree of the end of the exhaust stroke, the exhaust valve remain open. So both the valve remain open, mostly 25 plus 15 means about 40 degree, maybe different in different types of engine. So this period is called the overlapping period. It is obvious from the valve timing diagram that the inlet and exhaust valve are open at the same time. It is called the valve overlap, say about 15 degree in low speed engine and 30 degree in high speed engine. Depending upon the types of engine, the valve overlapping may be different. In our case, inlet valve start open before 25 degree and exhaust valve remain open in the power stroke at 15 degree. So the overlapping time will be 25 plus 15, that is we can say 40 degree. So this is the overlapping period of 40 degree in which inlet valve as well as exhaust valve both remain open. See, if we see the opening and closing of the valve, then inlet valve remain open 10 to 25 degree before top dead center depending upon the types of engine. Then inlet valve close. Inlet valve closes 30 to 50 degree after piston reaches to the bottom dead center. So opening in earlier and closing after the bottom dead center increase the entry of the fresh air, and complete cylinder is filled up with the fresh charge. So facilitate the fresh charge to enter maximum inside the cylinder. This opening of inlet valve earlier and closing it late will give maximum efficiency to the 4-stroke engine. Then exhaust valve open 30 to 45 degree before piston reaches at the bottom dead center. So this is the early time of 30 to 45 degrees, so that the exhaust valve can be fully open during the exhaust stroke. And exhaust valve close, it is closed late 15 to 30 degree after piston reaches to the top dead center. So opening early and closes late of the exhaust valve facilitate total expel of the exhaust gases and to prepare the cylinder for filling complete volume with the fresh air. Then fuel injection opens, means fuel injection start. It may be 5 to 15 degree before piston reaches the top dead center during the compression stroke, and it's remain in action, or we can say fuel injection remains in action after the piston reaches at top dead center and traveling to the bottom dead center during the power stroke. It may be 15 to 25 degree rotation of the crankshaft. During the earlier cycle, when exhaust stroke is continue, then at that time piston is traveling from bottom dead center to the top dead center in the earlier exhaust stroke. So at that time piston is just away 25 degree rotation of the crankshaft, the inlet valve opens and our inlet stroke start, and inlet valve remain open after piston travels from bottom dead center to the top dead center at the compression stroke up to 30 degree rotation of the crankshaft. So 180 plus 25 plus 30, this whole rotation of the crankshaft, the suction stroke continue and inlet valve remain open. After that this compression stroke start, and in the compression stroke, as and when piston is just away 5 degree from the top dead center, the fuel injection start and it remains continue up to, we can say, 25 degree of the crankshaft rotation with respect to the movement of the piston from top dead center to the bottom dead center. So mostly we can say round about 30 degree rotation of the crankshaft, the fuel injection remains in action. After that, the fuel is burnt and exhaust gas is produced, and that exhaust gas is expelled out after the exhaust valve open, and this exhaust valve start to open at just about 45 degree in advance when piston is not reaches at the bottom dead center. Means in the power stroke, piston is traveling from top dead center to the bottom dead center, and as and when piston is at 45 degree away of the rotation of crankshaft in the power stroke, the exhaust valve start to open and it fully open, and then exhaust gas is expelled out and it remains open, exhaust valve remains open up to 15 degree in the, we can say, piston is reaches at top dead center and traveling towards the bottom dead center. So to expel out all the burnt gases and producing the situation to have maximum amount of fresh air in the suction stroke, the exhaust valve start to open 45 degree in advance and it closes 15 degree late during the next cycle of the suction stroke. So both the valve remain open, 25 degree inlet valve and this 15 degree exhaust valve. So totally 40 degree is the overlapping period during which both the valve remain open. So this is the, we can say, actual valve timing diagram. In ideal condition, we can understand according to top dead center and bottom dead center of the movement of piston, but to facilitate the full opening and closing of the valve start to open in advance and it closes in late to have maximum amount of expelling of the burnt gases as well as to have more volume inside the cylinder to admit the fresh air.